Okay, so most of you on that you already, you are already get through that thing. Okay. However, we did the most emphasize cho the new take two. That means last semester you take one. Now you go moving to take two. Okay. So first thing we're talking about number. This will be done very quickly. Okay. Number system code, you get a decimal. Okay. Everyone already know number decimal. They get only 10 digits, start from 0 up to 9. And that's why they call a base 10. Okay? And basically, you're working on digital. Then you try to get along with that binary number system. Basically, they get only 2 digits, either 0 or 1, nothing else. That's why they call a base 2. Okay? The next one, octal number system, they're not using anymore. Okay? They get 8 digits, 0 to 7, and base 8. The thing is before in the computer, they get 2 number system, octal number system, and next one will be hexadecimal number system. Okay? Now they're using hexadecimal. That will be 16 digits, 0 up to A, B, C, D, E, F. Okay? Binary to decimal conversion. For example, if you get number 11011, that's a binary. Okay? You understand whatever inside the computer. Only one thing the computer can understand is the binary, nothing else. However, we're using the decimal. Okay? So that's why this is telling you if you get a binary, how can you convert it into the decimal? Okay, first thing you take 1 times 2 power of 1, 2, 3, 4, power of 4. Adding 1 times 2 power of 3. Adding 0 times, okay, 2 power of 4, of 2, and keep going. So then you add them up. The answer will be 27 base 10. Computer can understand 11011. However, we can understand that will be 27 base 10. Exactly the same when you're using your calculator. You cannot enter binary. You enter the decimal. Like you enter 27. Then in your calculator, they converting into 11011. So they can send it to the CPU, to the computer. Okay. And now the next one will be a decimal to binary. Okay. If you get a decimal at 25 base 10, and now you wanted to see what the binary is supposed to be, this is showing you how can they do it. They take 25 divided by 2. You get 12. Okay. Remainder will be 1. Then you take 12 divided by 2. you get 6. And remainder is 0. Okay, the question is, the first one, how come you get remaining of 1? And the second, you get remaining of 0. How you get that number? Just a minute. Hello. Chưa có đụng gì tới hết. Ok. Rồi. Ok. Just a minute, okay?
Okay.
Okay, so now you can tell me how come you get remaining of 1 on the first and the second one, you get remaining of 0. How?
Is it because it's a even number?
Yeah, 2 divide 25 2. Okay, so you can see 25. Basically, you get what? 24, right?
2.5.
Then the leftover will be 1, right?
Correct.
Yes.
Okay, so that's why you get 1. And the next one, you take the number 12, divide 2, you get 6. So that's why
0.
0. That is how come you get 0 or what?
6 divided by 2
Yeah,
is 3. But no
And 6
remaining.
by 2, okay, you get 3. Yeah. Okay, and 3 divide 2, you get 1, right?
Yep.
And 1 divided by 2, you get 0. You get a 1. So basically, they're telling you 25 decimal equivalent to 11001 in the binary. Okay? The thing is, human using the decimal, computer using the binary. Okay? So that's why we need to convert it and hash to binary. If you get a hash decimal, hash number 9F2, B16 mean the hash decimal. And now you want converting into the binary. Easy one, converting x1, number 9, equivalent to 1001. Number F will be on 111, and number 2 will be 010. Okay. They said require 4 bit for each number. Okay. And then now we will be converting binary to hash. If they given you that binary here, they want to know what the hash decimal. You want to be a technician, you want to be an engineering. This is a basic thing we have to do. If you get a binary and they want to go into hexadecimal, from the right to the left, divide by 4. 1, 4. Then you converting for x1, 1, 0, 1, 1. They will be B. I will be giving you the table. Okay. Okay. 1, 0, 1, 0, A. 0, 1, 1, 0, number 6. Okay. X 4-bit group in binary. Okay. The next one, I not go through it octal. We're not using octal anyway. BCD code, that's what we call a binary code decimal. When a number, letter, or word are represented by the special group of the symbol, this is called encoding. If each digit of the decimal number is represented by its binary equivalent, this produce the code will be called BCD, binary code decimal. For bit, it requires to code each digit. Example, you get the number 874B10. That's in BCD. Okay. You want to convert to BCD. This is a decimal. Easy way to do. First thing, you converting for number 8, 1, 0, 0, 0. They must be 4-bit. The next one, 7, will be 0, 1, 1, 1. The last one, number 4, will be 0, 1, 0, 0. Okay? That means BCD, binary code decimal. Except 3 code. Okay? That's just for your knowledge. Okay? We're not using. Perform same BCD. Except that 3 is added to each decimal digit before encoding in each binary. Okay, so basically we're not doing anything. Alphanumeric code ASCII. If you go to the web, you type in ASCII. Basically, they given you a table. Okay, letter, symbol, everything will be converting what binary number. Okay. Now, in the digital, they're working on 1 or 0. 1 is logic high, and 0 will be logic 0. And by definition, in electronic binary represented by the voltage or current, V high, okay, minimum is 2 volt and 5.5 volt. So when you go working on the circuitry you measure, you get 1.2 volt, completely draw. Okay, we don't have any logic for 1.2, 1.5, or 1 volt. Okay, that means some must be wrong. Second thing, you can see in display here, okay, that for maximum high, that for low, and this from this part right here, they say unacceptable. Okay, that means if you measure between 2 volt up or less than 0.8 volt for low here, that means something must be wrong. Okay, And now you can see, in here they show you the clock signal. That means the zero, high and low, zero, high and low, keep going forever. Okay? That's why when you go to buy the computer, okay, they can ask you, what the frequency you want. Okay, 8 gigabyte, 8 gigahertz or whatever. Higher clock, computer will be run faster. Okay. And also they can give you this is a bit. Okay, they can be zero, go high, zero, go high, and keep going. That's just a signal. So basically, you can see in the binary, you just deal with the high or low. Now, when you're looking only see this signal, positive going positive. That means only one. The zero, then they going high, then they go back to zero. Okay, that's they say positive going, positive. Okay, rising edge or leading edge, that going up, leading, going down, trailing. And another one you can see, same thing. That signal will be going low, then going high again. Okay, yeah, just leave it there. Thank you. That's okay. I do it. Okay, sorry. So when you see the signal, okay, this is a positive going, positive. This is a negative. That means they put high then going low. Okay. So basically this part here they call a leading edge, trailing edge. Okay. And now if you see this signal here, if you want to see what is the period, they going high, okay, going low and going high again. That will be one period, okay? And if you want to know the frequency, you already learned, right? You get the period. You want to get the frequency, F equals 1 over T, okay? And also this part, they going high, they go a TW, okay? And if you calculate the duty cycle, they will be calculated by TW divide period time 100%. How many percent of duty cycle? Okay. And that is normally you can see to where the computer can send in the data. The data can be sending serial data. That one. Serial data, that means you can need only one wire. Okay. And the signal sending on the serial. You see that? 1 0 1 0 whatever, they keep going. Okay, so basically signal sending a serial. You can see where you can see that signal. That signal will be you see on the telephone line at your house. Okay, the thing is they need only one wire, so they can send too many bits. The thing is when you're talking or listening, the signal will be sending through the wire. If they're not using the serial, you don't have a room to get enough wire for too many bits when we're talking. So that's why on the phone, signal transmitter have to be serial. And then the next one will be parallel data. Parallel data here, you can see 1, 2, 3, 4, 5, 6, 7, 8 bits. One wire sending only one bit, logic 1 or logic 0, whatever. Okay, so basically inside the computer, they're using the parallel. Okay, so now if you buy the computer, how many wire for address a new one? Who knows? For a new computer, how many wire for the address?
Should be 8.
Thing is, your computer, you get an address and also you get the data.
Is it 64 or 32?
64.
64.
64 wire for the address. So that's why they can run really fast compared to the old one they get only 32 wire. Okay? And the data before the 8-bit, 8 wire, 16-bit, 16 wire. Now 32-bit, 32 wire. Okay? So basically the computer cannot do with any serial. Okay? However, outside they're using the serial. So that's why you can get the device, okay, converting serial to parallel. Outside the computer, data going serial. However, when you get inside the computer, they must be converting to parallel data. Okay? If you already on the textbook last year, you're learning a IC 74164 that converting from serial to parallel. Okay, this is the table. Okay, telling you what the decimal, okay, and what is the binary. So 0, 1, 2, 3. In the binary 4-bit, 0, 1, 2, 3. Okay, you can look into that. Okay, and what they telling you, the maximum number will be 2 power of n minus 1. The thing is, the decimal start from 1, binary from 0. Okay, that one everyone already know. This is your calculator. Okay, if you type in the number 9. Okay, so the computer inside computer cannot understand the number 9. Then I have to convert it to the binary. If you're looking into here, number 9. Okay, right here. So they will be 1, 0, 1, 1, 1, 0, 0, 1. No, here, sorry. Okay. So that's why inside the calculator, they will be converting 1, 0, 0, 1. Okay, the device converting from the decimal into the binary, they call a encoder. You have to understand the thing when they're talking about that, and you don't know what that means. What an encoder? What encoder doing? Basically, in your calculator, that device converting the decimal for the human, converting to binary for the computer can do it. Okay. And next one will be decoder. Okay. Binary coming in. Okay. And human cannot understand. So that's why they have to using the segment here in order for the human. You typing number 8 binary. Okay. Computer send out binary number 8. They go to the decoder and they will be display number 8. So you can understand. So that's what they call a 7-segment display. On the left, you get one left, right? For this 7-segment.
Yep.
Okay. So try to understand what encoder doing.
Okay.
And that will be what decoder doing.
Okay. Thank you.
Okay. And now they say convert the following binary to the decimal. Okay. This one, your guy can do it. I already get the answer. If your question will be coming, asking me next time. Okay, next one. Binary addition. Okay. You adding binary 0, 0, 1, 1, adding to 0, 1, 0, 1. 0 adding 0. You get 0. Sum 0. And the carry 0. 0 adding 1. You get 1. Sum will be 1. However, carry will be 0. 1 adding to 0. You get 1. However, carry still be 0. 1 adding to 1. Okay, you get 0. However, carry 1. That's an easy, okay, for your guys to know. Converting following number, binary, to the decimal. Okay. We already get the answer. You can try. Binary addition, like we just talking about. Only thing in here, pay attention. 1 adding to 1. Answer will be 0. However, carry 1. Now, what that mean carry 1? Carry 1 mean adding 1 to the next column. Okay. Now we want to adding 1, 1 to 1, 1. Okay. What you supposed to get? Okay. 1, 1. Okay, first thing 1 adding to 1. Answer will be 0, right?
Yes.
That's what you see right here, 1 adding to 1. is 0.
Yes.
However, carry 1. Okay, what that mean? Carry 1 mean adding 1 to the next. That means you have to adding 1 here. One
So
adding
we'll be moving
1.
over.
Yeah. You adding to 1 to the next column. 1 adding to 1. 0. 0 adding to 1. Is 1. And still carry. Right? Still carry.
You'll carry 1.
Right. So now try to see. Decimal, what number here? Right? 1 is number 3. Next one will be number 3. Number 3 adding number 3. You get number 6. This is the answer. 110 equivalent number 6.
I'm not gonna turn the 4, but you.
Okay? So basically, what you need, try to do it for the next one, to see what you get. Okay? We don't have much time to go over. Next one, binary subtraction. That means 0 minus 0, you get 0. 0 minus 1, you get 1. However, they say, okay, borrow 1 mean subtract 1 from next column. Okay? 1 minus 0, you get 1. 1 minus 1, you get 0. Okay? So they given you example. 1 minus 0 1. 1 1 0 1.
Qué pedo.
1 minus 1 0. Okay? 1 minus 0. So now you see that number will be number 3. This number will be number 1. 3 minus 1, you get number 2. Okay? And now try 1 1 minus 2 1 0. 1 minus 0, you get 1. Okay? 1 minus 1, you get 0. Okay? Let's see. We try it. Next one will be 1 1 0 1. Minus 0 1 0 0.
Dicen que no, ¿está bien?
Okay, so that is simple. I get a last one.
Señor.
1 0 0 1.
Te doy el SKU, te doy el part number. El part number está bien raro.
Minus
Ok, ahí está. B de Benito. 85. Tomás. Miguel.
Somebody needs to mute their mic.
just a minute. Okay. 1 0 0 1 minus 0 1 1 1. So 1 minus 1, you get 0. 0 minus 1. Okay, you can see right here. 0 minus 1 equal 1 with the borrow 1. That means on that one here, you get 1. Okay, borrow 1 mean subtract 1 from the next.
Column. Yeah,
That is subtract right here.
yeah.
Okay, 0 minus 1, you get a 1. 1 minus 1, you get a 0, right? Still subtract 1 from here. 0 minus 1, you get 1. 1 minus 1, you get 0. Subtract 1, still get 1 here. 1 minus 1, 0. 0 minus 0, get a 0. Okay, so basically you get number 0, 1, 0, 1, 0. That is number 9. 0, 1, 1, number 7. And that answer will be number 2. 0, 0, 1, 0, number 2. That's how you subtraction. Okay, next one, quickly. First complement a binary number. Okay, by changing 1 to 0, 0 to 1. That's easy. So basically, you get this number. Binary number. And they want to know converting first complement. Converting first complement very simple. It was 1 change 0, it's 0 change 1. That's why first complement. Now, why we need to using first complement? When you get only binary, the computer don't know this is a positive number or negative number. And the computer have to deal with both, either positive or negative. So that's why they have to using the first complement number to deal with positive and negative. Okay? And also the same for second complement. Same thing. That means that will be have to computer to take care for positive and negative. Like when you try to deal with +5 or -5, that means negative number. Then the computer have to be using first complement or second complement to take care. Normally the system they're using only one, either one. Now they normally using the second one, second complement. Second complement, you can get it by adding 1, okay, to the least significant bit of the first complement. So in order to get a second, first thing you have to get first complement. Okay, this is the number here. They want in the second complement. First thing you get first complement. Then you adding 1. That telling you is a second complement. Okay, this is a thinking, you do it. Okay, a side number we don't care for now. Side bit we don't care for now. The thing like that goes into too many details inside the computer and nothing to do with the electronic technician. Okay, that's a side bit. We skip that. We don't need that. Okay, this is a table telling you one we're using all the time. Relation between the decimal, binary, and hexadecimal. Okay, This is the hexadecimal. Decimal number 10, the height will be A. 11 B, C, D, E, F. Okay. And binary will be 1, 1, 1, 1. Decimal will be number 15. Okay. If you want to converting from decimal to binary or binary to hexadecimal, you need this table. Okay. Convert it, the following decimal number will be go to BCD. Okay. A35. Okay. B98. Okay. You can see in here. Okay. 98, that means number 9. 8 will be number 8. That coming out from this table. BCD, addition. Okay. If you go to the college, then you have to know. However, for this program, we're not dealing with that much calculation. Okay, so I don't care. Will be gray code just for your knowledge. Okay. In the code, they can get a gray code. Okay, gray code is unweighted and is not an arithmetic code. That is, there are no specific weight assigned to the bit position. Okay, the important feature of the gray code is that it exhibits only a single bit chain. Okay, so basically you can get a decimal and this binary and this is a gray code. Okay, first thing 0, 0, that's 0. 1 will be 1. 2 will be 3. Okay, that's gray code. That means when you be engineering, they have to design something, they need the gray code, so that's why they can go to that. Okay, only thing is, if you get a binary, you want to change to the gray code here. You get 1, 0, 1, 1, 0. Okay, if you want to converting a gray code, first thing 1 going here, and 1 adding to 0. Okay, you get 1. Okay, and 0 adding to 1, you get 1. 1 adding to 1, 0, no carry. Okay, 1 adding to 0, that's 1. That's a very simple. And we get the example if you want to exercise. Okay, and now you get a gray code. You want to change to the binary. Gray code 1, 1, 0, 1, 1. You want to change the binary. First thing, that one, you get 1. Take that one, adding 1, you get 0. No carry. Then you get a 0 adding to 0, you get 0. And you get a 0 adding to 1, you get a 1. 1 adding to 1, you get 0. No carry. That's a very easy to converting from the gray code into the binary. Okay, ASC. Okay, basically we don't care. If you want to see the number, letter, whatever on the online, you type in ASCII, they given you the table. Okay, the next one. Law and rules, Boolean algebra. This is just a basic. Okay, now if you get the A is a variable, in the binary. You say A is a variable. What A equal?
Any number?
If I say I get the A is a variable in the binary system, what A equal? They can be either 0
Or 1.
or 1. Okay? If they not equal 0, they equal 1. Or A equal 1, then they not equal 0. Have to understand that. So the rule first one, A, okay, adding 0 equal A, easy to recognize. A adding to 1, you get a 1. Anything adding to 1 have to be a 1. Okay, I can get an example here. 1 adding to 1 adding to 1 equal what? You have to tell me. One adding to one adding to one. What is supposed to be equal? Who knows? Nobody knows?
No.
Mr. Smith, do you know one adding to one adding to one, what you get?
Should be 3.
That's quite. If you say 3, that's quite wrong. Why? In the binary, you don't have a number.
Because it can only be 0 or 1.
So that should be 1 then.
Perfectly.
Then it crosses out.
Third equal to 1. We're talking about logic. Okay, now, when you're working with a digital lab or any digital circuitry, okay, 1 mean what voltage?
Higher than 2. 5 volt or higher than 2 volt.
Yeah, that's a logic one.
Yeah.
However, if they say connect pin, this pin to the logic 1, then you have to connect to 5 volt. In the binary, you get only 2. If they connect to 0,
Oh, right.
you connect to,
Yeah. Ground.
yeah, you get only 2. Either
Right.
5 volt or ground.
Yeah.
When you connect A to 1, B to 1, C to 1, that means you connect that to 5 volt. Okay? You can get either 5 volt or ground in the binary. Okay? Nothing else. So, now, if A times 0, you get 0. A times 1, you get A. A plus A, you get A. You can say, I just talked to you. 1 adding 1 adding 1, you get 1. A adding A, you get A. A adding this one need to correct here. Not A, you get 1. A times A, you get A. A times not A, you get 0. You understand on that? If A equal to 1, time not A will be opposite A, 0. You understand? A or not A, okay? A equal 0, not A equal 1. A equal 1, not A equal 0. Okay? A times A, you get A. Okay? A not equal A. What that mean? If
So
you
it's just A.
1, okay, you get a not, you get a not. Either they write this way or they can write this way. Not. So double not. First one inverted, you get 0. And 0 inverting again, you get 1. So that's why they telling you A not equal A. Okay. Now A or AB. I can guarantee some student, even you've been here before, you still cannot really understand. Let's see. A or AB. The answer will be A. How come you get that? First thing, A or AB, I can put A. Open the bracket. A will be 1. Adding B. You can see 1 or B equal what?
A.
That means 1 adding to B. 1 or B. What equal? I'll give an example. 1 or A or B or C equal what?
One, yeah.
1 or with anything have to be a 1 anyway.
Yeah.
So 1 or B equal 1, right? 1 times A. So that's why they say right here. A or AB equal A. Okay. And the next one, A or AB. Now that have to be correct. Maybe A equal
A plus A not B.
A not B.
Yeah.
That how come this one is not
I'm not sure why. Yeah, there you go.
A not B. Okay. Equal AB. Okay. Or A plus B times A plus C. A or BC. Okay. And now, sum of product. Okay. X times Y not. You see, this is a not. If you want to break it out, X will be not X. X times Y. Okay. That means you have to be converting to or. Okay. Not X or not Y. Okay. And now product of sum. If you get not X or Y, you don't want that not here. Take that out. X will be not X. Or will be converting N and not Y. Okay? And get. Okay, so quickly we can get up to the point. Okay? This is the symbol for the AND gate. AND gate, they get at least 2 input A, B, or 3 or more. Doesn't matter. Okay? But normally you're working on 2 input and the output Y equal A times B. Okay? And this is the truth table. A and B. Okay? 0, 0, output 0. 0, 1 is 0. 1, 0, you get 0. You get only 1 if input A and B equal to 1. Okay? So in here they try to explain to you. 2 input and gate. Okay? Truth table. That's a truth table. Okay. The part number 7408. Okay. General. 2 or more input for AND gate. 1 output. Output is 1 if on input must be 1. Okay. That means 1 input 0, they have to be 0. The thing is you time with 0 anyway. You get 0. So this is the IC. Okay. This IC, they get a pin 1 up to pin 14. Normally IC to be working, they need to get the power. That's what 5 volt, VCC, and they have to get a round. Okay. For the 14 pins, pin last one 14 will be 5 volt, and pin 7 will be round. So when you build a circuitry, first thing, you have to connect power and connect a round. Okay? And you understand, inside the IC 7408, you get 1 AND gate, 2, 3, 4. And they're telling you, pin 1 input, pin 2 input, pin 3 output for the first gate. Okay? So even they using only 1 gate, but they have to still using the IC. The other one we don't using doesn't matter. Okay? If you get a question, you can asking me, okay? This is OR gate. Simple look like. Input AB. Output will be Y equal A plus B. And this is the truth table. Okay? 0 adding 0, you get 0. 0 adding 1, you get 1, 1, 1. Okay? That only they telling you. Okay? 2 input or more. 1 output is 0. If on input is 0. A0, B0, then you get 0. Either 1 equal 1, you have to get a 1. Okay? The IC part will be 7432. And this is telling you, inside IC, you get 4 gate and pin 14, VCC 7 round. Okay? When I'm looking in the OR gate symbol, I don't need to see the truth table. I know if you get both input is 0, then output 0. 1 input is 1, output must be 1 anyway. And this is inverter. The part number 7404. Inside you can get 1 gate, 2, 3, 4, 5, 6. Pin 1 input, pin 2 output, and so on. Okay. Inverter, just opposite. This is the symbol. If you get A0, output have to be 1. A1 output have to be 0. Just opposite. Then now you go to what we call a NAND gate. This is the symbol for the NAND gate. This one, they telling you the bubble here, just an inverter. They substitute by inverter here. Okay, 2 input A, B. Output will be A and B. Then go to inverter, you get the bar over. Okay, that is the bar over. Okay, that means you don't want the bar. Okay, you want to convert it to normally. Take separately. A will be not A. N will be O, not B. Okay, so basically this is a truth table. Input A0, B0, you get a 1. 0, 1, you get a 1. 1, 0, you get a 1. Only thing 1 and 1, you get a 0. Okay, that means if the A1, B1, you get 0. However, 1 input equal 1, you get the 1. Okay, and this is the IC. Normally, this is telling you pin number 1. Okay, and 14 and 7 will be power and ground. Inside they get 4. 1, 2, 3, 4. First one, pin 1 input, pin 2 input, pin 3 output of the first gate. So when you get along with that one, very simple. Not gate, nor gate. That means not gate. This is a symbol. They get the OR, then they add the inverter right here. Equation will be Y equal not A or B. Okay? If you don't want not A or B, you try to convert it. First thing, you can see A will be not A. Or converting to N. B will be not B. Instead, they say not A or B. You can see easy to recognize. Not A time, not B. Okay? And this is a truth table telling you. Okay? If I'm looking on this table here, output will be equal to 1. Okay? If A0, B0, then you get a 1. Okay? Otherwise, any one input equal to 1, you can get 0. And this is the IC. 1 gate, 2 gate, 3 gate, 4 gate. Which pin input, which pin output. Last one here. Okay? That will be exclusive OR, exclusive NOR. When you see this symbol, the name will be exclusive OR. How they work it? They get a truth table here. 0, 0, you get output 0. 0, 1. 1 here, you get a 1. 1, 0, you get a 1. 1, 1, you get a 0. Easy to recognize. If you get AB the same logic, output 0. If you get AB different logic, output will be 1. And this is an exclusive NOR. The difference is you get a bubble right here. And the truth table, they working opposite to the inclusive OR. You can see that 0, 0, now you get a 1. Just opposite. Okay? Okay, that's it. Now, what I want you to do, make sure if you get a friend telling him, have to be in the U, have to be in the any the review in 2025. And also they will be have to do on the DLab. Keep doing. You don't have a much DLab for your guy from phone 2024. But most of the DLab will be a big one. Okay? It's not easy to get through it. So that's why I figure out a way. I try to organize in the room 240. I can using the camera up there to working with your guy. Much better than in the U. Okay? That will be more practical. And I can recognize right away who can show up, who never show up. If you never show up in the lecture, forget it. Okay? You can do 10 lab completely. I don't care. You understand you get only 1 day lab, 1 day lecture. If I'm working on Monday, then on Friday we will be free. Sometimes we be need, then I can do on the Friday also, but it's not normal. So we need the time. I can organize in the room 240. I can using the camera up there. I can show up so we can do more practical. Okay? I can give you example. And let's say now the lab number 9. How many people done? Okay? Then I can let you run your lab. And now they say, pass, that means okay. And now I make it not working. Then when you run, they fail. You have to tell me what you want to do. That's what I'd like to teach you. Also, you can see in the system we're using the clock, positive clock, P clock, and negative clock. And when you run the test fail, the clock disappears. You cannot see it. So I will be teach you how can we take the clock. Do have a clock or not have a clock? Okay. Using the software, adding something. Okay, so that may be good for your guy. Okay, any question, anything?
No.
No.
Okay, if you see your guy not showing up, then telling him I will drop him out. Okay?
Okay.
Okay, so have a good weekend for everyone. Okay.
You too. See you
Thank you,
next
Professor.
week.
Thank
Have a
you,
good night.
Professor.
Have a
Chúc
great
mừng năm mới
weekend.
thầy. Chúc mừng năm mới thầy.